When performing a simulation using ASAP, you can use either the source models that come within ASAP, items from this source library, or you can input data, such as from a Radiant source file. In ASAP, all you'll need to do is import the data itself, and we'll show how that works. I'm just going to open a blank INR file, and just to set the basics, I'll use the basic template that comes from the template library. Don't need to worry about any media or any geometry definitions. Right now, we're just going to look at how we'd import the source. And to use a radiant imaging source, we simply need to tell ASAP that we have an emitting data file, and then we'll input the name of the file. In this particular case, the name of the file is XRE, and it's the measurement of an LED source. The data file must have the extension .dis, and this is an option in the Radiant source program. Now that I've told ASAP what my source is, let's let ASAP read that source and give us some information about it. So what I'm going to do is do a spots position command, and since I have a rather large ray set, about 500,000 rays, maybe I'll only plot every 100th ray on my spot diagram, and I'll also do the same thing with the spots direction command. Since I'm not going to do any ray tracing right now beyond looking at the source, I can comment out this command right there. And now let's just let ASAP import the data and give us our information. The Radiant source models are simply the goniometric output from the source. There's no information about the physical geometry of the source, but it is an accurate representation of the light that is leaving the source. As long as the light doesn't have secondary interactions with the body or the geometry of the LED, it will give a reasonably accurate representation in your ASAP simulation. Now, our spots position is indicating the location of the rays on the surface of the LED body. And our spots direction gives us information about the direction cosines of the rays that are leaving the surface.